In multi-view projections, the plane of projection is kept between us and the object. Here, the definition of our multi-view projection is put better into words. The second statement, which states the object is oriented such that only two of its dimensions are shown, makes more sense in the next slide, where I've shown a bad orientation of the object inside the box and a good orientation. As you progress through the course, the orientation just becomes common sense. Before we move on to the slide which shows good and bad orientations, here once again is the third angle projection, and below it is depicted first angle projection. Once again, in North America, most of the drawings follow the third angle projection convention. Projection is much more intuitive to how you observe the object inside the box. As you can see, the top view is placed directly above the front view and the right side view is directly to the right of the front view. Here now you can see a general idea on how to position your object inside the box and what it means to have only two of the dimensions of the box being seen in one view. You'll observe some hidden lines in each of these diagrams. We'll go more in depth into the hidden lines in lectures further into the series, but just for your information, hidden lines are used to represent features that are found on the inside of the object and not really on its exterior surface. A very common example of a feature that is generally depicted with hidden lines is a hole. A hole generally partially or completely passes through the object, so you cannot really depict the entire depth or length of the hole using the thick outlines, because that feature of the hole is interior to the object. So then you use hidden lines to depict the limiting elements of the hole. Here is the list of lines that you'll find in your drawings. The ones marked with red markers are the one you'll find most commonly. The visible line is also known as the outline. The hidden line used to represent hidden features. The center line used to represent the center of circular features. It is generally the point from where the radius is measured. The lines that are indicated as thick are generally drawn with a harder hand with a darker shade of pencil, and the thinner lines are generally drawn much more lightly. You can either use different types of pencil leads to draw these lines, but I got through my course using the same pencil and varying the pressure I applied onto the paper. Whatever works best for you. Now are the multi-views of some very common solids. The multi-views are indicated in the third angle convention with the top, front and right side views. It'd be best to pause at some of these solids and really ponder over whether the shapes depicted in the diagram are similar to the multi-view drawings you would have visualized in your head. If not, you can review all the stuff we have discussed until now regarding the box method visualization and then come back and try to visualize these objects. This might seem pretty easy to a lot of you, but for some of you who haven't taken a geometry related class in a long time, I knew I struggled with this when I started my class because I really did not know how to construct parallel lines. It's rather simple. You either use the 45 and 60 set square or your set squares along with your ruler in order to construct parallel lines. I'll attach here a small video clip of just a small demonstration regarding how you can draw a line parallel to a given line. Just like everything else in this course, even this technique is fairly intuitive. The first step always involves keeping one of your instruments edges aligned with the line you want to draw a line parallel to. In my case, first it was AB, and then you use the other instrument as a kind of a pivot. You fix the second instrument's position so that you can now move the first instrument freely. If it sounds too complex and mumbo jumbo right now, trust me, just take out your instruments and start drawing parallel.